In this section, we're going to talk about quadratic equations and how to solve them. So first of all, we want to talk about what is a quadratic equation. Well, it is an equation that can be written or rearranged into this format here. Ax squared plus bx plus c equals 0. So notice that the goal is to make the one side equal to 0, and the other side will have something with degree 2 in it, okay? Also notice that we order this from biggest exponent to smallest exponent, or in this case, no exponent, all right? If we do that, then we know which thing is A, which thing is B, and which thing is C. Now, A, B, and C need to be real numbers, and A cannot be 0, because if A were 0, then the first term would disappear entirely, and then it wouldn't be a quadratic anymore because it wouldn't have an x squared in it. Okay? Now, sometimes we call this a second degree polynomial, and that's because it has an exponent of 2. It is the second degree. All right. So, the zero product principle is something that we use a lot to solve these equations. If we can factor a quadratic equation where we have two things multiplied by each other equal to 0, then at least one of the factors is equal to 0. What does that mean? Well, if A times B equals 0, then either A equals 0 or B equals 0. Has to be true. If A doesn't equal 0, then B would have to equal 0, or else it just doesn't work, okay? So the zero product principle, or sometimes you'll hear of it as the zero product property, means that when you multiply two numbers and they equal 0, one of them has to be 0. Okay, so when we solve equations by factoring, we're going to first make sure that it's in this format. And that may mean we need to rearrange. So move everything to one side so that the other side can be 0. Okay? Then we're going to factor the left side in this case. We're going to set each factor equal to 0 because of the zero product principle. We're going to solve both equations to find our answers. And then we are going to check our solutions in the original equation. Make sure you're checking both. There's always a chance that you'll get one right, but then the other you may have lost a sign. So always check both equations. Okay. Now, let's take a look at this one. First of all, we'll notice that it doesn't equal 0. So we need to make it equal to 0. So I start by figuring out, what do I want to move? Well, I'm going to move the 1 because then I only have to move one thing. Okay, so I subtract 1 on both sides. That gives me 2x squared plus x minus 1 equals 0. Now I need to factor it. So when we factor this, there are a couple different ways you can do it. Okay, in the past I've taught the asterisk method. Guess and check is okay, but not ideal. You can also do a couple other things like factoring by grouping, the upside down Lizzie method, but I'll go ahead and remind you what the asterisk method is. First you have A times C on the top, B on the bottom, and the top sides, and then put these little question marks, okay? And we need to find two numbers that multiply to the top and add to the bottom. So in this case, A is 2, C is -1. So 2 times -1 is -2. B is what's in front of the x, and that in this case is 1. So even though it doesn't look like there's anything there, it's technically 1. And my A is 2, so I write A and A. Now I need to find two numbers that multiply to -2 and add to 1. Well, the good news for this one is that there isn't a lot of things you have to try. The answer is going to be +2 and -1. We're almost done. Remember, our two rules that have to apply here are, first of all, the negative has to stay wherever the negative is. Okay, so when you have a negative in the bottom of, we're going to look at this like a fraction, bottom of the fraction. It's going to stay there, all right? And when we simplify, then it also still has to stay a fraction. We still need two numbers involved. So when we look at this one over here, 2 over 2 does simplify, and normally we would just write it as 1 when we simplify that fraction. But because we're doing this in asterisk method, we're going to do 1 over 1. That's going to make it so that we have the two numbers we need. Now, we come over here, and we're going to translate what we wrote in our asterisk into factored form. So 1 over 1 becomes 1x plus 1. So 1 over 1 is 1x plus 1. Now, 2 over negative 1 is 2x minus 1. Okay, so 2, negative 1, 2, negative 1. Okay? And then we still set it equal to 0. Now, by the zero product principle, if x plus 1 times 2x minus 1 equals 0, then either x plus 1 equals 0 or 2x minus 1 equals 0. I can solve these now. This one gives me x equals negative 1, and this one over here is going to give me 1/2. So these are my two answers. But remember, you do want to go back and double check your answers. So when we do that, assuming this is on a calculator portion of any test that you're taking, all right, we're going to, ta-da, here's a calculator. We're going to plug it in. So we have 2 times negative 1 squared plus negative 1. Hey, look, it equals 1. Okay, now let's do the same thing with 1/2. 2 times 1/2 squared plus 1/2. Now, I do know some people like to do the little fraction symbol, but remember that fractions and division are the same thing. So just using divide is fine, and voila, it comes out to 1. So I've checked it, yes. Now, let's talk about the square root property. Now, if we have something that's not in that standard form, instead it's in this format here where you have something squared equals d. Okay, so something squared equals another number. Okay, then we're going to be able to use the square root property. And one of the keys here is when you take the square root of both sides, you have to account for both the positive and the negative value of the other side. Okay, so if u squared equals d, then u equals plus or minus d. So what does that mean? Okay, well, example. Let's say I had x squared equals 9. I'm going to take the square root of both sides. X equals, well, the square root of 9 is 3, but I have to put a plus or minus in front of it because x could be positive 3 or it could be negative 3, because think about it. 3 times 3 is 9, and negative 3 times negative 3 is also 9. So both 3 and negative 3 would be valid answers in that case. So let's take a look at how we can apply that to a problem that looks like this. You'll notice that this has a degree 2, okay, so it has x squared in it, but it doesn't have an x. That's the key to knowing that it's going to be a square root property. Now, in this case, I'm going to go ahead and subtract 45 from both sides, and that's going to give me 5x squared equals negative 45. Now I divide by 5. I have x squared equals negative 9. Now, let's recap for a moment. When we look back here, you're going to look and see that we had x squared equal positive 9, gave us plus or minus 3. Now, when we look at this, we know, okay, this time it's negative 9. What does that change? Okay, well, I take the square root of both sides. And at this point, it's important to know, is it asking for a real answer or all answers? If it's asking for a real answer, the answer is there's no solution because you can't get a real number out of the square root of a negative. However, you may be asked for a complex answer. And at this point, you can do something with it. So the square root of 9 is 3, but the square root of -9, whenever you have a negative under the root, you're going to have that I, okay, for imaginary numbers. So remember to look at the question about whether or not we're including complex values. Now, even though it's complex, we're still going to have our plus or minus in front. All right, let's talk about the binomial x squared plus bx. It's a binomial because there are two things, all right? And we want to add a third. This is so that we can do what's called completing the square. Completing the square is going to allow us to rewrite this x squared plus bx into something squared. So when I say something squared, I mean we're going to be able to factor it so that it's the same thing twice. So what do? Well, we're going to find the b value first of all, okay, figure out what b is, then find what b divided by 2 squared is. That's what you have to add to the end of the binomial to make it factorable as a perfect square. So just a quick example, all right? Let's say I gave you x squared plus 8x, okay? In that case, my b is 8. So b divided by 2 squared is 8 divided by 2 squared is 4 squared is 16. So when I'm adding 16 at the end of this, I can now factor this and I ask myself, okay, a times c is 16, b is 8, a is 1. What two numbers multiply to 8 and multiply to 16 and add to 8? Well, that's 4 and 4. So I can factor this to be x plus 4 times x plus 4, which is the same thing as x plus 4 squared. And what you're going to notice is that this number here, the 4, is really just our b divided by 2. So our b was 8. When you divided it by 2, you get 4. That's where this number comes from. So you're welcome to jump straight from here to here using that rule if you like. Now, when we're solving by completing the square, we do have to do a little bit of extra work. It has to start by having the binomial on the left. That means that you have to move the c value, in this case the -1, over to the right side. So I'm going to add 1 to both sides. Now I have x squared plus 4x equals 1. Okay, so again, make sure you start with only the two things on the left side. Now we want to find our b value. Okay, our b value is 4. And that means we're going to find b divided by 2 squared by doing 4 divided by 2 squared, which is 2 squared, which is 4 again. So that means I'm going to add 4 right here. But now that we're working with an equation, we have to remember that what you do to one side, you have to do to both. So we added 4 to the left. We're also going to add 4 to the right. So the left side, I could now factor. And we say, okay, b is 4. B divided by 2 is 2. So this becomes x plus 2 squared. Remember, you can still factor it the way that you did on the previous page if you like. Now that equals 5, because 1 plus 4 is 5. Now I'm going to go back to using that square root property we talked about. Okay, I have to do the square root now because x plus 2 is inside parentheses, so I can't get to it until after I've handled the square root. So I take the square root of both sides. The left side, the square and the square root cancel, so I have x plus 2. The right side, I don't know the square root of 5, like I can't simplify that, so I write root 5, and I remember right now to put my plus or minus on the front. Okay, last but not least, let's get x by itself. We have to move the 2. So we subtract 2 from both sides. X equals -2 plus or minus root 5. And that's going to be our answer. So don't forget, you can't combine the 2 and the 5 because the 5 is under our root. If you could combine them, you would. But again, these are not like terms, so you're stuck. Okay, quadratic formula. Da -da 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 -da. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, we're going to try this one more time. I know some of you sang along. If you didn't, though, this next one, all right? The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, hopefully this is something that you already have memorized, but if not, look up the quadratic formula song. Listen to it on loop. You'll have it memorized. Lickety split. Okay. So how do we use that? Well, first of all, note that A is 2 and B is 2 and C is negative 1. So when I have x equals, and notice that I do need to start with x equals. I can't just jump straight into the formula because I need to say what I'm solving for. And here I am solving for x, okay? Negative b is negative 2 plus or minus the square root. B squared is 2 squared minus 4 times a is 2 times c is negative 1. Make sure you carry that square root all the way over. All over, and you'll notice that that fraction bar goes under the whole thing. 2 times a, which is 2. So we're going to go ahead and simplify some stuff here, okay? So I have negative 2 plus or minus the square root. 2 squared is 4. Then I have minus 4, 2, and negative 1. And I need to multiply all that together. So I'm going to have plus 8. And on the bottom, 2 times 2 is 4. I finish combining like terms underneath the square root, and I get negative 2 plus or minus the square root of 12 over 4. Some people are tempted to simplify the fraction at this point, but don't. Remember that you have to simplify root 12 first. So root 12, the biggest perfect square that goes into 12 is 4. And it goes in 3 times. Square root of 4 is 2, that comes out. So root 12 is really 2 root 3, okay? So I can now say x equals negative 2 plus or minus 2 root 3 over 4. Now at this point, to simplify my problem, I'm going to split the fraction. So I'm going to have negative 2 over 4 plus or minus 2 root 3 over 4, because then it's easier to cancel what I need to cancel. Negative 2 over 4 simplifies to negative 1/2, and I have my plus or minus still. 2 root 3 over 4 simplifies to root 3 over 2. This is our simplified answer. And notice that it's still x equals. As a follow-up note, if we have things, if we have an equation, we don't know how to solve it, factoring is the easiest way to solve if it's factorable. But quadratic equation and completing the square will technically always work, even if it's not factorable. Okay, so keep that in mind. Also, remember that on any test that you're given, if it says use quadratic equation, you have to use quadratic equation. If it says solve by factoring, you have to solve by factoring. Solve by the method that's told to you. Unless there isn't one said, then you can do whatever you like. All right, let's talk about the discriminant. The discriminant is part of the quadratic formula, okay? So it's b squared minus 4ac. It's the thing under the square root in the quadratic formula. It's going to tell us how many solutions and of what type there are. So this is sort of a shortcut to know, do I have one solution, two solutions? Are my two solutions real, or are they complex? You know, I can kind of do a little look over to see what kind of answer I'm going to get. So let's look at an example, okay? Or let's look at a list. So if the discriminant is positive, there will be two unequal or distinct different real solutions. But if it's 0, there is one real solution, and it just technically is repeated. That means it happens twice, but we only write it once, okay, because there's only one number involved. And if the discriminant is negative, there are two imaginary solutions. Okay, that means that there's going to be the I involved. Okay, so when you're looking at a problem, you'll now know ahead of time what kind of solutions you should be getting. So b squared minus 4ac is greater than 0. There are two real solutions that are different from each other. B squared minus 4ac equals 0. There's one real solution. B squared minus 4ac is less than 0. There are two imaginary solutions. All right, now let's look at that example. So in this case, I have b squared minus 4ac. Well, b is negative 7, so I have negative 7 squared minus 4 times my a is 2. C is negative 4. Okay? Negative 7 squared is 49. And then minus 4 times 2 times negative 4 is going to be positive 32. Okay? I'm going to add those together, and I'm going to get 81. Now that's a positive number. It's greater than 0. So that means I have two real solutions. Ta-da! All right, let's talk about how quadratic equations can be applied to real life. So this formula here, P equals 0.01a squared plus 0.05a plus 107, models a woman's normal systolic blood pressure P at age A. We want to use this formula to find the age to the nearest year of a woman whose normal systolic blood pressure is 115 millimeters. Oh, HG is something. I know the answer to that. Someone in the class should probably know it too. Hemoglobin? Someone asked the science teacher. All right. So in this case, though, they tell us that our blood pressure is 115. That means that I need to plug in 115 for the p-value. So I have 115 equals 0.01a squared plus 0.05a plus 107. Now, in order to solve a quadratic equation, it has to equal 0. So I'm going to subtract my 115 to the other side. Cancels here. And I have 0 equals 0.01a squared plus 0.05a. And 107 minus 115 is negative 8. Now, I look at that and I think to myself, all right, there are lots of decimals there. I'm thinking maybe I don't want to try factoring because it would be maybe a little much. Okay, doesn't mean that's not factorable, but it might be a little extra work to figure out how it factors, and we don't know either way. So I could either complete the square, or I could do quadratic formula. When I have an odd number in the middle, or if I have decimals, I tend to lean towards quadratic formula. So the quadratic formula is, first of all, we have to write a equals this time. Okay, that's a key part, because if you don't write a equals, then we're wrong, because look at what we're solving for. It's a. It's not x anymore. So always make sure you're writing the correct variable down. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I'm going to do part of this in my calculator, but I'm still going to take notes on each step. Okay, so when I have my calculator here, I'm going to start by turning it on. There we go. All right, I'm going to start by doing the discriminant. So that means doing the 0.05 squared minus 4 times 0.01 times negative 8. Okay, so that gives me 0.3225. So I have negative 0.05 plus or minus the square root of 0.3225. Now, on the bottom, 2 times 0.01, I can do that. That's 0.02. All right, then I'm going to take the square root of my answer. And notice that I'm just going to use the answer button. I'm not going to even bother typing 0.3225 again. All right, and that's going to give me this mess. Now, I don't even really want to type that. So I'm not going to. So I'm going to use a little trick in the calculator. That's my store button. Okay, so I hit store. Ta-da. And I'm going to store it in the letter A. So that you have to press the alpha button here. Store A. Okay. And that's going to now make, anytime I use the letter A, I'm going to make it that 0.567890836 without having to type it all out. So I'm going to find my two answers. I have to do negative 0.05 plus A, close the parentheses, divided by 0.02. Okay, and that's going to give me one answer. And then I'm going to do second entry is the enter button. And I'm just going to go back and change this to minus for my second answer. So I get two answers. I get A equals, we'll say 25.9 and negative 30.9. Sorry, negative 30.9. Now, we go back to the context of the question. We say, okay, do both of those answers make sense? Well, it's asking us to solve for age. So we figure probably a negative age doesn't make sense. So we say the woman with normal systolic blood pressure of 115 millimeters Hg is, well, it says to the nearest year, about 26 years old. So remember to restate what it is that you're finding and then put your answer with a unit. So in this case, rounding to the nearest year, so it's 26 years. Now in the Casio, if you're wondering how to do the store, okay, it's going to be a similar setup, but it's this button here, it's this arrow. So when you turn it on and you go to your main screen, okay, let's say we did our 0.05 squared minus 4 times 0.01 times negative 8, and we took the square root of our answer. Well, yep, let me fix that. There we go. Shift answer. There we go. We can then hit this button right here to store. So little arrow, alpha A. Okay, everything else is exactly the same. Voila. So let's take a look at some example problems. This one says to use factoring to solve the quadratic equation. Then check by substitution, or if you want to use your graphing calculator check, that is fine. All right, so some people like to do that. Go ahead, give this a try. So remember, in order to solve things by factoring, you have to first move everything to one side. So I need to move the 7x and the 30 to the left by subtracting both. So this becomes 2x squared minus 7x minus 30 equals 0. I go ahead and I look to see if there's anything I can pull out of everything. And I can't pull out 2, 7, and 30 don't have a greatest common factor. So I'm out of luck. So now I'm going to jump straight into the asterisk. A times C is negative 60. B is negative 7. A is 2. And I need to find two numbers that multiply to negative 60 and add to negative 7. Now, I'm getting negative 12 and positive 5. But remember, if you don't know, write out factors of negative 60, like 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that'll be it. But then it multiplies to a negative, so one of them has to be negative. And it adds to a negative, so it's got to be the bigger one that's negative. And look, there it is, 5 and negative 12. All right, so now I can translate what I just did into, well, first of all, 2 over negative 12 simplifies to 1 over negative 6. And that's going to give me 1x minus 6. 2 over 5 doesn't simplify, so it's 2x plus 5. And this equals 0. Now I'm going to set each piece equal to 0, so x minus 6 equals 0. 2x plus 5 equals 0, and I'm going to get two answers of 6 and negative 5 halves. Remember to check your answers back in the equation. Try this one using the square root property. So for the square root property, we start by adding 8 to both sides. We have 2x squared equals negative 32. Now we'll divide by 2 on both sides, and x squared equals negative 16. To finish solving for x, I'm going to have to take the square root of both sides. That's why it's called the square root property. So I have x on the left. The square root of 16 is 4. It's negative 16, so I have to actually add my I in. And because I took a square root, I also have to remember my plus or minus. Double check that your paper has the plus or minus. If it doesn't, you only have one out of the two answers. Try solving this one by the square root property. So for this one, we're going to take the square root of both sides. And that's going to give us x minus 5 equals, well, we say 4. But what do we have to put in front of the 4? Plus or minus. Now we're going to add 5 to both sides, and we get x equals 5 plus or minus 4. Remember that if you can combine them, you should. 5 plus 4 is 9. 5 minus 4 is 1. So we get x equals 9 and 1. Try doing this one by completing the square. So to complete the square, I need to find my b value, which is 4. I'm going to divide it by 2 and square it. So that's 4 divided by 2 squared, which is 2 squared, which is 4. So I'm going to add 4 to both sides. That gives me x squared plus 4x plus 4 equals 36. Now if b equals 4, we know b divided by 2 is 2. That lets us know that this is x plus 2 squared equals 36. To finish the problem up, I'm just going to use my square root property like I did on the last slide. I take the square root of both sides. That gives me x plus 2 equals plus or minus 6. Now, I subtract 2 on both sides. X equals negative 2 plus or minus 6. I can combine those. Negative 2 plus 6 is 4. Negative 2 minus 6 is negative 8. Ta-da! All right, to solve this one by completing the square, I'm going to work this one out with you. Okay, but go ahead and write it down. I want to point out that the leading coefficient is not 1. This one requires us to do a little bit of extra work. First of all, you still have to move that c value over. So add the 1 to both sides. So we have 6x squared minus 6x equals 1. Now the next thing we have to do is we have to get rid of this coefficient. Because if we don't, then we have the problem of we can't do the b divided by 2 squared bit. So you have two options. You can either factor it out or you can divide it over. All right. I personally do a factoring. So I have 6 times x squared minus x equals 1, like that. Okay. Now my b is -1. So b divided by 2 squared equals -1/2 squared equals 1/4. And that's what I'm adding inside here. The trick is if I'm adding 1/4 inside the parentheses, I have to distribute the 6 to it, okay, to figure out what I add to the other side. 6 times 1/4 is 6/4, which is also known as 3/2. Now, I can write this as 6 parentheses. This is going to be x minus, well, if my b is 1, -1, okay, then when I divide 2, I get -1/2 squared, and 1 plus 3/2 comes out to be 5/2. To finish solving, I'm going to divide both sides by 6, but I think of it as multiplying by 1/6, because then it comes over much more nicely. I have x minus 1/2 squared equals 5/12. And then you're going to solve by square root property. Try finishing that for me, and I will see you guys later.